79, problem number 11 reads, sketch a scatter plot of the data. Use the regression feature of a graphing utility to find a linear model for the data. Estimate the elongation of the spring when a force of 55 kilograms is applied. All right, let's take this one at a time. First of all, sketch a scatter plot of the data. That means we're going to take our x and y values and plot them on a graph. Now, in this case, our force is acting like our x, our elongation is acting like our y. Now, I'm going to label my x-axis force, and my y-axis I'll just label with an E for elongation. Let's get a scale on here. For force, it looks like I need a tick mark. I'm going to put a tick mark every 20 units. So this last one will be 100. For elongation, I need to go up to about 7, so I'll put a tick mark every 1 unit. And we can just barely squeeze that in up here. So now to get these points, for force of 20, elongation is 1.4. For force of 40, elongation is 2.5. For force of 60, elongation is 4. For force of 80, elongation is 5.3. And for force of 100, elongation is 6.6. Now, we might not have a perfect line, but it looks like our points are in a actually very close to a straight line. That's our first part, a scatter plot of the data. Second part, use the regression feature of a graphing utility to find a linear model for the data. That means let's get out our graphing calculators. Let's graph these points and find a model for the data. So to do that, let's press our stat key, and I'll press enter to edit my statistics. What I need to do is type in these values. First of all, I'll get my values of force, or my x values. Once I type those in, I'll get my values of y, or my elongations. So there's my force values. Now elongation, whoops. Now once we have all these in here, our calculator can give us the best fit linear model, the best fit line through these points. We can use a formula to do this. It's pretty complex, but the calculator can do it for us very quickly. Let's press our stat key again. Now, we started by editing our statistics. Now we want to calculate something. We want to calculate, look at the fourth choice, linear regression. We want to calculate a linear regression model in the form ax plus b. It's like y equals mx plus b, just written as ax plus b. I want to look at the data in list 1, so I'll press second 1, comma, list 2. So the data in list 1 and list 2. When I press enter, it gives me the best fit linear equation. So my equation, it says y equals ax plus b. So I can write y equals, instead of writing ax plus b, I can plug in these values of a and b. So y equals 0.066x, and then plus 0. Do I have to write the plus 0? No, not at all. So there's my best fit equation, my linear model. Now, third part. I need to estimate the elongation of the spring when a force of 55 kilograms is applied. So looking at my force, that's my x. So that's like saying, let's take this number 55 and let's plug it in place of x. So it's like saying, what's the y value? What's the elongation when I plug 55 in place of x? Let's use this over here to help us out. So 0.066 times 55 tells me that that value is 3.63. Now we can verify that, or we can estimate if that is close to where it should be by looking at my table. If my force is 55, does it make sense that my elongation is 3.63? Yeah, it seems to fit. We can also estimate on our graph, do those values fit? They seem to fit, so I think my answer is okay.